Welcome to The Deep Dive. Today, we're jumping into something that's, well, pretty much everywhere in tech and business now. Cloud computing and networking?
It really is fundamental.
Yeah, and getting a handle on the key ideas and, the language around them is super important. Not just for tech folks, but for anyone in business, really. Helps with clear communication.
Absolutely. And it's also a great way to pick up some of that specific business English and tech vocabulary you hear flying around.
Exactly. So our goal today is to unpack the core concepts from the material we've reviewed. We'll break down the jargon, explain how things work, and why it all matters.
Right. We want to help you feel comfortable and, well-informed when these topics come up. Less jargon, more understanding,
Yeah.
and maybe help you use these terms confidently yourself.
Perfect. Practical understanding, practical language. Let's get started.
Let's do it.
Okay, first big question. People talk about the cloud all the time. What actually is it? Sounds kind of vague.
It does sound a bit floaty, doesn't it? But fundamentally, the material defines it as a network of remote servers. Think huge buildings packed with computers, data centers, run by companies like Amazon, Google, Microsoft.
Okay, so not actually in the sky.
Definitely not.
Hmm.
They deliver computing services, things like storing your files, running databases, powering websites, analyzing data, but they do it over the internet. So instead of owning all that gear yourself, you access it remotely.
Got it. Remote computers doing stuff for you via the internet. Simple enough. The material also digs into these key characteristics. Why are these important to understand? What makes the cloud, well, the cloud?
These are crucial. They're what differentiate cloud computing from older models, like just renting a server somewhere. They explain the advantages.
Right. So let's take the first one, on-demand self-service. It mentions provisioning resources instantly. What's that mean in plain English?
Okay, so provisioning resources is really just a slightly formal way of saying getting access to computing power or services like servers, storage, databases. The on-demand self-service part means you can get these things yourself right away, usually through a web portal, without talking to a salesperson or waiting for someone to set it up manually.
So you can just click a button and get a server?
Pretty much, that's what spin up a server means, quickly getting a virtual computer ready to use.
Yeah.
It can take just minutes. You might hear a developer say, I'll just provision a new database instance. It's about speed and autonomy.
Okay, that speed sounds useful. What about broad network access?
This one's fairly straightforward, but key. It just means you can access these cloud services from basically anywhere with an internet connection, using almost any device, laptop, phone, tablet.
So work from anywhere.
Exactly.
Yeah.
The material emphasizes via any device. It breaks down those physical location barriers.
Makes sense. Next characteristic, resource pooling. The example used is AWS serving millions from shared data centers. How does that work?
This is all about efficiency for the provider. They have these massive pools of hardware servers, storage, networks. Resource pooling means they share this shared infrastructure among many different customers or tenants.
Shared. So my stuff is running on the same physical machine as someone else's?
Potentially, yes. But it's all logically separated and secured. Think of it like an apartment building shared foundation, roof, plumbing, but everyone has their own secure apartment. The provider manages the pool and allocates resources as needed.
Yeah.
It keeps costs down.
Okay. So shared infrastructure, but private spaces. Got it. Then there's rapid elasticity, scaling up or down, handling traffic spikes.
Right, so scaling up or down means adjusting the amount of computing resources you're using. More power, less power.
And traffic spikes.
That's just a sudden surge in demand. Think of retailer's website on Black Friday or a news site when a big story breaks, lots of people hitting it at once. Rapid elasticity is the cloud's ability to automatically add more resources, more servers, more power to handle that spike, and then, just as importantly, shrink back down when the spike is over.
Automatically.
Yes, that's the key bit. You don't have to predict the spike perfectly or manually add servers in a panic. The system reacts. You might hear, we configured auto-scaling to handle traffic spikes. Very powerful.
So you're not paying for capacity you don't need most of the time. That links to the last one, measured service. Pay only for what you use.
Exactly. This is the pay-as-you-go model.
Yeah.
Unlike traditional IT where you buy servers up front, here the cloud provider meters your usage, CPU time, storage space, data transferred very precisely.
Like an electricity meter.
Kind of, yeah.
Yeah.
You pay based on your actual consumption. It changes IT costs from big capital expenses to ongoing operational expenses. This is why people talk about optimizing cloud spend, making sure you're only using and paying for what you really need.
That cost model is a huge deal for businesses. Okay, those are the core features. Now, let's shift to how companies actually use the cloud deployment models.
Right. This is about where the infrastructure lives and who manages it. Different ways to set things up.
Let's start with public cloud. The source says shared infrastructure, third party, like AWS or Azure.
This is probably what most people think of first. The infrastructure is owned and run by a third-party provider, Amazon, Microsoft, Google, etc., and it's shared by many customers, hence public.
Like those shared data centers we talked about with resource pooling.
Exactly. It's generally the most cost-effective and flexible option, especially for startups or companies with fluctuating needs. Easy to get started.
Okay, third-party provider just means it's another company, not your own IT department. Makes sense.
Mm-hmm.
What about private cloud? That's dedicated infrastructure, single organization, banks, for example.
Right. In a private cloud, the infrastructure is used exclusively by one organization. It's dedicated infrastructure, meaning hardware just for them.
Where is this hardware?
It could be in their own data center or hosted by a provider, but still totally separate and dedicated. Companies with really sensitive data or strict regulations like finance or healthcare often go this route for more control and perceived security.
So dedicated is the key word there, just for one company. Then we have hybrid cloud, a mix of public plus private.
Yep, very common. You use both. Maybe you run your main website on the public cloud because it needs to scale easily for lots of visitors.
Okay.
But you keep your super sensitive customer database or maybe your inventory management system on a private cloud for tighter control. Hybrid means connecting these two environments so they can work together.
Best of both worlds, potentially. And the last deployment model mentioned is multi-cloud, using multiple providers like AWS and Google Cloud. Why do that?
Good question. The main driver here is usually to avoid vendor lock-in.
Vendor lock-in.
Yeah, it means not becoming totally dependent on a single cloud provider. If all your stuff is with one company, they kind of have you over a barrel regarding pricing or features. If they have an outage, you're stuck.
Ah, I see.
Using multiple providers gives you more leverage, resilience, and maybe lets you pick the best service for a specific job from different clouds. You might hear someone in strategy say, we're pursuing a multi-cloud approach for risk mitigation.
Spreading the risk.
Yeah.
Smart. Okay, so that's how clouds are set up. What about the types of services you get from the cloud? The cloud service models, IaaS, PaaS, SaaS.
Right. Think of these as layers of service, or how much management responsibility you take on versus the provider.
Okay, bottom layer first. IaaS, infrastructure as a service. Renting virtualized hardware. AWS EC2 is the example.
Exactly. With IaaS, the provider gives you the basic building blocks servers as virtualized hardware, meaning software versions of physical machines, storage, networking,
So like the raw components.
pretty much. You rent this infrastructure, but you manage everything on top of it. The operating system, the applications, the data, security patches. It's the most flexible, but also requires the most IT expertise from your side. Like renting an empty building, you decide what goes inside and how it's run. DigitalOcean is another example, often used by developers.
Got it. Raw infrastructure. Moving up a level. PaaS, platform as a service. Development tools plus environments, like Heroku or Google App Engine.
With PaaS, the provider manages the infrastructure and the underlying operating systems, databases, and other middleware. They give you a platform, the environment, and development tools specifically designed for building and running applications.
So developers don't worry about the servers.
Exactly. They can just focus on writing code and deploying their app.
Hmm.
The provider handles all the platform maintenance. It's like renting a fully equipped workshop. You bring your project and the tools are ready for you. It speeds up development significantly.
Convenient for developers. And the top layer. SaaS, software as a service. Ready-to-use apps like Gmail or Salesforce.
This is the one most people use daily without maybe even thinking of it as cloud. SaaS delivers complete software applications over the internet. You just log in and use them, usually through your browser.
So no installs, no managing updates.
Nope. The provider handles everything, the infrastructure, the platform, the application software itself. They are truly ready-to-use apps. Think email, CRM, collaboration tools, office suites like Microsoft 365 or Google Workspace. You just subscribe and use.
IaaS is the foundation, PaaS is the workshop, SaaS is the finished product you use. That clicks.
Great. Now, all this cloud stuff relies heavily on the network connecting everything. So the material also covers some key networking concepts that are really tied into cloud performance.
Right, like latency. What is that exactly? Sounds important.
It is. Latency is basically just delay. The material defines it as the time delay between sending data and receiving a response. Think of the round-trip time for a message.
Repay a delay. Why does it matter so much? The source says high latency, slow apps.
Because even small delays can make things feel sluggish. If you click a link and it takes ages to load, that could be high latency. Video buffering, that annoying pause while it loads, is often caused by latency issues.
Ah, okay.
And for anything real-time online gaming, video calls, stock trading, high latency can make the application almost unusable. Low latency is key for responsiveness and a good user experience. You'll definitely hear tech teams talk about reducing latency.
How do you reduce it? The source mentions CDNs.
A CDN, or Content Delivery Network, is a system of servers spread out geographically. They cache data, store copies of website content like images and videos closer to users. So instead of fetching an image from a server across the world, you get it from one nearby, cutting down the travel time.
Like having local warehouses for data?
Good analogy. And optimizing code means making the website or application software itself run faster, so the server can process requests and send responses back more quickly. Both help shave off milliseconds, which add up.
Makes sense. The material also breaks down the HTTP request lifecycle. Sounds complex, but it's just how a web page loads, right?
Exactly that. It's the step-by-step journey from you typing a web address
Yeah.
to the page appearing. Happens incredibly fast, usually.
Step 1. DNS lookup. Turning a name like google.com into an IP address.
Right. Computers talk using numbers, IP addresses. But we use memorable names, domains, like google.com. DNS, the domain name system, is like the internet's address book. Your browser asks DNS, what's the IP address for google.com? Someone might say, check the DNS records if a site isn't working.
Address book. Got it. Step 2. TCP handshake, connecting client and server.
Before data can flow, your computer, the client, and the website server need to formally greet each other and agree on how they'll talk. That's the TCP handshake, a quick back and forth to establish a connection. Ensures reliable communication.
Okay, connection established. Step 3. HTTP request. Your browser asks for the page.
Yep. The client side message, the HTTP request, saying what it wants, like, get me the file index.html, which is often the main page of a website. It's the actual asking part.
Then step 4. Server processing. The server figures out the answer.
The server receives the request, finds the file, maybe runs some code, queries a database, and puts together the response. It does the work.
Step 5. HTTP response. Server sends the answer back.
The server sends the data back across the internet. This HTTP response includes a status code, like 200 OK or 404 not found, headers with info about the data, and the actual content of the body, the HTML, images, etc.
And finally, step 6. Rendering. Your browser shows the page.
Your browser takes all that code and data from the response and turns it into the visual web page you see. Puts all the pieces together. All that happens in the blink of an eye, usually.
Amazing how fast it works. Now, related to HTTP is HTTPS. The S is important, right? Secure version using encryption.
Hugely important. HTTPS adds a layer of security using encryption, usually TLS or SSL protocols.
Why is that secure version so critical? The source mentions encryption and authentication.
Encryption scrambles the data between your browser and the server. So if a hacker intercepts it, they can't reach your password or credit card number. It's just gibberish to them.
Crucial for sensitive stuff.
Absolutely.
Yeah.
And authentication verifies the website's identity. It proves that the site you're connected to really is your bank, for example, and not a fake site trying to steal your login. It's called phishing.
Right, you look for the S in HTTPS and the padlock icon. The source uses the bank example https.bank.com. vs http.bank.com makes it clear.
Definitely. And there's another benefit noted, an SEO boost. Google and other search engines prefer secure sites, so using HTTPS can actually help your website rank higher in search results. Good for business visibility.
Security and better visibility. Win-win. Okay, let's quickly touch on a few advanced cloud terms from the material that often come up.
Sure, these add a bit more nuance to cloud discussions.
First, the difference between scalability and elasticity. They sound similar.
They do, and they're related, but there's a key distinction. Scalability is about the ability to handle growth, designing your system so you can add more resources later to cope with increased load, like planning for Black Friday sales by adding servers beforehand. It's often a planned capacity increase.
Okay, planning for growth. How is elasticity different?
Elasticity is more about automatic and immediate adaptation. The source highlights the automatic aspect, like AWS autoscaling. The system automatically scales resources up or down in response to real-time demand fluctuations, those unexpected traffic spikes we mentioned.
So scalability is the potential. Elasticity is the automatic reaction.
That's a good way to put it. Scalability is, can it grow? Elasticity is, does it grow and shrink automatically? You might hear, the architecture is scalable and we've implemented elasticity.
Got it. Next up, redundancy, defined as duplicate systems to avoid downtime.
Redundancy is all about reliability. It means having backup or duplicate systems in place. If one component fails, a server, a disk, even a whole data center, a redundant copy takes over automatically, so the service keeps running. This helps avoid downtime, which is when your service is unavailable. Backups across multiple locations are a classic example. You'd say, we need redundancy for this critical service.
Insurance against failure. Makes sense. Then serverless computing, like AWS Lambda, running code without managing servers.
Yeah, this one's quite cool. Serverless doesn't mean no servers, but rather that you don't have to worry about them at all. You don't provision, patch, or manage servers.
So what do? You
just write your code in small functions, upload it, and the cloud provider automatically runs it whenever it's triggered, say, by an image being uploaded or an API call. The provider handles all the underlying infrastructure scaling. You pay only for the execution time. The image upload example is great. A function automatically resizes images as they arrive. You might hear, let's build that feature using serverless functions.
Very efficient for event-driven tasks, okay? Identity and access management, or IAM, controlling who gets access.
IAM is fundamental cloud security. It's the system to control who can access cloud resources and what they can do. You define users, roles, permissions. The example of restricting database access only to administrators is perfect. It ensures people only have the permissions they need to do their job, the principle of least privilege. You'd often ask, what IAM role do I need for that?
Essential for security and compliance. Last advanced term, service level agreement, for SLA, a contract guaranteeing uptime.
An SLA is that formal promise from the provider to the customer about service quality, most commonly guaranteeing uptime or availability, like saying the service will be operational 99.9% of the time.
What happens if they don't meet it?
There's usually a penalty, as the source notes. Typically, the provider gives you service credits or a partial refund if they fail to meet the agreed SLA percentage. It gives the guarantee some teeth. You definitely review the SLA before signing up for critical service.
Okay, phew. That's a lot of ground-covered basics, models, services, networking, advanced terms.
It is, but hopefully broken down it makes more sense. From what the cloud is, to how it's used, the types of services, how networking impacts it, and some key operational concepts.
So let's bring it back to the listener. What does this all mean for you in your job? What's the real business impact?
Great question. Understanding this stuff isn't just academic. It has real-world consequences. First, cost savings. That pay-as-you-go model often means lower upfront IT costs compared to buying and maintaining your own hardware.
Money talks. What else?
Security. We talked about HTTPS and IAM. Using cloud security features correctly helps protect vital company data from breaches and unauthorized access.
Performance.
Big one. Low latency means faster applications, which translates to happier customers, more productive employees. Better performance is better business.
And compliance, meeting regulations.
Right. For industries with strict rules like healthcare, heat IP, or finance, using hybrid or private clouds can be essential to meet those data privacy and security regulations or compliance requirements.
The material also briefly mentioned a few other usable terms in passing. CDN.
Yeah, content delivery network. We touched on. It speeds things up by caching data closer to users globally. Cloudflare is a big name there.
VM.
Virtual machine, the software emulation of a physical server, like an AWS EC2 instance. A core IaaS building block. You might say, let's launch a new VM.
And Kubernetes. Sounds complicated.
It can be, but it's hugely popular. It's for managing containerized apps. Think of containers as little standardized packages of software. Kubernetes helps automatically deploy, scale, and manage potentially thousands of these containers, especially useful for modern microservices architectures. Often abbreviated K8s, you'll hear, we run our application stack on Kubernetes.
Okay, we've really covered the landscape today, from cloud basics to networking to some pretty advanced stuff, and importantly, why it matters for business.
And the main takeaway, really, is that getting comfortable with these terms helps you collaborate better, especially with technical teams. It lets you understand costs, make smarter decisions, and ensure the systems you rely on are secure and perform well. It boosts your effectiveness and, hopefully, your confidence using this kind of business and tech English.
Absolutely. Hearing them explained and used in contexts like this hopefully helps cement them.
Right. Listen for them in your own workplace.
So as we wrap up, here's a final thought for you, the listener, to mull over. Looking at all these concepts, the different cloud models, latency, IAM, scalability, SLAs, which one feels most relevant or maybe most impactful in your specific role right now? Is it how your company uses a hybrid setup? Is latency critical for your customers? Does IMM affect your daily access? Thinking about that personal connection can really deepen your understanding.
It's a great exercise, connecting it to your own world.
Thanks for joining us on this deep dive. We hope this has demystified some of these crucial cloud and networking ideas and the language around them.